everyone, and welcome back to another Miss Pollard Math YouTube video. Today we are going to be going over functions, and more specifically when these functions are positive, negative, increasing, decreasing, and its overall end behavior. Like I always say, the most important part to start with is the vocab. Without the vocab, we're not going to be able to solve these problems. So what does it mean to be positive and negative? For a function to be positive, that's when the graph is above the x-axis. For it to be negative is when it's below the x-axis. And a great way to remember this is when a function or graph is above the x-axis, its y values are positive. So that's why that would be positive. And when it's negative, the y values are negative. So it makes sense of where the placement is. For a function to be increasing, that is when as your x values get more positive, your graph is going upward. Where for decreasing is as your x values get more positive, the graph is going downward. So this for increasing, it's upward as the x's get more positive, and this one for downward, decreasing, downward. Finally, end behavior. End behavior means at the end of our graphs, what is happening to our x and y values? Are they getting more towards negative infinity, more towards infinity? So we're going to take a look at what is happening at our end points of the graph. Let's take a look at an example problem to see how we would apply these vocab words. So we are given this graph, and we need to determine when it's positive, negative, increasing, decreasing, and its overall end behavior. So let's start at positive because that is the first vocab word I gave you. So it's positive when our function is above the x-axis. Keyword was above the x-axis. It's not when it lies on the x-axis. And why does that make sense? That makes sense because our y value is 0, and 0 is not positive nor negative. It's neither of those. So we cannot include when our function hits y as 0. So let's take a look. Our function is positive when it's above the x-axis. It's above the x-axis all here to here. We can't include the 0. And from here to here. That is when our function is positive. We need to make inequalities for these, and as you see, I shaded it, I colored where it is positive. This helps me to see how many inequalities I have to make. I'm going to have to make 2 because there's one here and one here. So let's look at these x values. Every time we're doing positive, negative, increasing, decreasing, we are looking at the x values. So our x value here is 0, and as we have this portion of the graph, our x values are getting less than 0. These negative numbers are less than 0. So our positive is going to be when x is less than 0. Along with, we are seeing that our graph is positive between here and here. And another key word that I said there was between. If we're talking about between, that means we need a compound inequality. Those x values are between here and here, which the x value here is 0 and 3. So it's going to be between 0 and 3, and once again, we are not putting or equal to. We're not putting or equal to because it's not including that 0 and 3. When x is 0, when x is 3, our y is 0, which, like I said before, is not positive or negative. Now let's look where it is negative. Those were our positives. Let's see where it's negative. It's negative from here downward. So let's see. Our x value there is 3. And as we're going down, our x values are getting bigger than 3. So our inequality is going to be x is greater than 3. All our x values that are greater than 3 have a negative portion of this function. Let's look at increasing. Increasing, we're going to have to think, where is our graph going upward? So let's look. We're going down, 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 down. Then we're going up, and then down. So where we're going up is where we have to be cautious of. So we're going up here. Our graph is going up between these 2 points. Once again, you heard me say between. It's not going on forever. It stops. So it's between 0 and 2. So we need our compound inequality between 0 and 2 for our increasing. Now for our decreasing, it is decreasing. All the ones here, downward, all the ones here, downward. So we are going to see which inequalities that works from, because this is not saying between, so we're not going to have a compound inequality. It's not between 2 points. This is going from our x values are 0. Once again, like we saw for the positive, our x values are getting less than 0 as it's decreasing. All of these over here are less than 0, so we're going to use x is less than 0 again. And then here, we're going downward, but as we're going downward, our x values are increasing. They're getting bigger, right? We start at 2, then go to 3, then keep on going to 4. So we're going to do x is greater than 2. As you can see, we're using similar numbers as we do this. We're having a 0, 0, 3, 2. So you're going to be using the same type of numbers. Every single portion should not have different numbers. I'm going to try to make this portion easier for you by giving you the options. So all you'll have to do is pick which options you do. But like I said, it's easiest if we shade which parts we're working with so you can visualize what we're doing. The last part of this is the end behavior. So we're going to see as it's ending, we call it end behavior. It's not stopping, but as it's getting more and more towards infinity, what's happening. And the books like to do it where we're saying as y is approaching something, x is approaching something. I like to look at the x values. I feel like that's a little bit more clear for my students. I personally don't care the way we write it. So if we're looking, my x values are getting more positive this way. So I'm going to erase this so I have more room. So my end behavior, I'm going to label it as EB. As my x values are going to positive infinity, let me put positive here, either or, as they're going to positive infinity, what are happening to my y values? My y values at the end. We're not looking over here, we're looking at the end, hence end behavior. My y values are going negative. So we say y is going to negative infinity. And the way that the book or other teachers might do it is as y is going to negative infinity, my x's are more positive, so you just flip the two. I'm fine with it this way. So that's one option. You're always going to have two. The other option is as my x is approaching negative infinity. So as my x's are getting more negative, my y's are getting more positive. It's going in the upward direction. So my y's are going towards positive infinity. So I know this problem is sometimes confusing for some people, so I'm hoping after I showed you each step and showed you how to draw where we're going to, that made it a little bit more clear for you.